Hi, this is Bits and Pieces, the official podcast of Component Supply. I'm Kristin, and today I'm so excited because we have with us Dave Splett from Injectech, and they specialize in standard and custom fluid management components. So, Dave, we are so excited to have you to join us on the conversation today.
Hi, Kristin. Thanks for having me. I really appreciate it, and I'm looking forward to this conversation.
Yes, me too. We met a few years ago at an MD&M show, and Component Supply has been stocking Injectech parts for a while now in small quantities, easy access for R&D, but the great thing about Injectech is that they can kind of grow with you, customize with you. But first, I'm always interested in the journey of someone into medtech. So I wanted to talk about how you got involved in fluid management in the medical device space.
Absolutely. So yeah, my journey started in college. I had the opportunity to take a Dale Carnegie course. I enjoyed it so much that I continued onwards. I volunteered as a graduate teaching assistant for the course. So post-graduation, I was still doing that. And in one of the classes, a CEO for a large fluid management company locally was one of the students. So I met with him throughout the classes, and on the graduation day, he asked me to come join his company.
Wow.
So that was my first postgraduate job, and I started in customer service. And within about 8 months, I was promoted to sales manager, where I'd go out and visit the top 200 customers annually. So
Wow.
That's how I learned about fluid management.
That's fantastic. I love when people can see something in you when they meet you in that kind of setting. Like you're not applying for the job, it's just a daily interaction, and they're like, I want to work with you. I think that's so wonderful.
Absolutely. I'm very grateful.
Oh, yeah, it's awesome. So you're now in Injectech. Tell us about that start and maybe give us kind of the bird's eye view of Injectech, what you're doing and what's ahead.
Yeah, absolutely. So Injectech is a customer-focused manufacturer of Luers, tube-to-tube connectors, both standard and high-flow connectors, filters, high-flow valves, and custom products. We were founded in 1998, started as just a part-time company, and then one by one, each of the founders left the other fluid management company and focused full-time on Injectech.
Wow.
Last year, we shipped over 100 million parts to 2,000 customers in over 30 countries. Yeah, we're very happy about that.
Yeah, I bet you are. That's fantastic. Congratulations.
Absolutely. Yeah, and then currently we have over 2,500 off-the-shelf and custom components that are offered to medical device OEMs and biomedical companies. And recently, as of last October, we joined the Vance Street group of companies. Through that, we have a new plastics platform, which offers fluid management components such as Injectech, Resinex, and we also have micromolding, silicone molding, and device development capabilities.
That's amazing. So, yeah, you have an incredible amount of capabilities for any kind of custom fluid management solution that might come your way with that team.
Absolutely.
So one of the things we loved about the Injectech model, because when Component Supply is looking for new vendors or new capabilities, we're looking for the symmetry between that hybrid model of kind of standard, off-the-shelf, readily available components for R&D, knowing that might not be exactly what they need, but it'll get them close, it'll get them to a concept, and they'll have to move to fabrication. So on the component supply side, whether it's metals or like tubing or wire or some kind of assembly, we try to have some representation on our shelf, and that's why we carry some of the Injectech line. But we also know that it might not stay there. It's a lucky day when that off-the-shelf product can work into all the way through the commercialization of the finished device, but we know a lot of times it will move to custom. So you have that hybrid model, and what do you see as being the primary benefit of that?
So we started off as a custom molder. And we grew into a catalog company. I would classify us neither as strictly custom or strictly catalog at this time. In our early years, we received numerous requests for Luers and tube connectors, and that's when we decided to release a product line of catalog components. When we were looking at developing the tooling for these product lines, we intentionally made the tooling modular so that it would be inexpensive to add on additional features to our core product lines, such as different barb sizes, barb styles, bond imports, or other custom features. So the benefit to our customers with our new hybrid model is that we leverage our own tooling to provide custom components to their design criteria while realizing lower tooling costs and lead times.
Yeah. So when you say it's a modular, you have is that like the base of the part kind of remains the same and then the features are what changes? Is that what that means?
Exactly.
Okay.
Exactly. So if you take one of our components and simply just split it in half, let's say you have a male lure or a female lure, we can keep that side the same and then customize the other side that connects to the tube, as opposed to quoting an entire mold base.
Right. So creating a cost efficiency and the lead time there, like you said. Okay. Gotcha.
Absolutely.
That's a great model, for whether it's someone who needs the standard part just to start with, or that they need to add their own spin on it, and you're able to grow with them. So is that the typical customer journey? Do you feel like most people start in that R&D, small quantities off the shelf, and then they move, or is there a different kind of journey that you see?
So the standard components are the majority of what we do. When we don't have an off-the-shelf solution for them, what we do is we review our custom components that are not exclusive to see if there's a match or a close match. If so, then we continue onwards with that. If there isn't a close match, then we gather the information that we're going to need, such as, does the customer have drawings, samples? What are the annual quantities? How is the component being used? Sterilization requirements. Do they want the part to be exclusive? Do they mind if we add it to our catalog? Their budget and time frame. So from there, what we'll do is we'll provide an initial estimate. And if the customer would like to proceed with a formal quote, then we further define their validation requirements, labeling and package requirements, and it results in providing a quote to them.
I love that model. I love that you don't just push them into custom if it's not necessary, or something completely custom, that you try to match them with something close. And then also you don't stop there. You're asking them all those beginning questions that I think not every supplier is asking, and not every engineer or product developer is thinking about necessarily. They're trying to make something work, but there are questions about how it's used, what sterilization requirements there are going to be that are going to affect your materials. So I do, and I encourage this for all of the manufacturers out there, to begin asking those questions early. So you guys are exactly right, because otherwise you might run into problems down the road and have to start over, and then you create a cost and a time frame problem that no one wants.
Absolutely. Yep. We like to gather all the information up front. It's easier for both parties.
Yeah. So we're talking really about fluid management for the most part with Injectech here. And so every conversation probably starts with a problem, because otherwise they would buy it online and call it a day. What are the problems that you see engineers facing at that first call?
From our experience, the customers are looking for a trusted supplier. The three main things that we've experienced, the three main requests, are high quality components, quick lead times, and fair prices.
Yep.
So we do our best to meet each of those. And then I'd like to also add on that we do have a very serious initiative about customer focus at Injectech.
I love that. It's all about building the relationship, knowing your customer,
Absolutely.
them knowing you, and I think kind of knowing the good, the bad, and the ugly. Like this, not everyone is perfect, and we can't all be everything to everyone. So having the honest conversation about any limitations that there are, any unrealistic expectations. I was at MPP East just last month, I guess, and one of the conversations, we've had this conversation on the podcast, is let's say you're evaluating between good, fast, and cheap, right? We've established we don't like the word cheap. That's
Right.
Nothing's cheap in the medical device industry because nothing is intentionally poorly made, right? So it's not, those terminologies aren't the best. It's just, quippy. But as I was thinking about it more, because we've had it too, we're like, if you could only pick two, what would they be? But really, I think it depends on the phase of the project, right? And it's not that you can't have it all. You just can't have it all at maybe the same level, right? And every customer is different on their expectations. Some might be willing to loosen a spec to have it faster because it's going to work. It's not as critical of an application versus something might be, hey, we'll take a little bit of a longer lead time, but you have to have it perfect. So I know those beginning conversations with you, you're probably evaluating that with your customer as well, getting them to establish realistic expectations.
100%. Yep.
You have informed us recently of, I guess we kind of knew about it, but almost it's like a lot of other standards. It's far off into the distance until it's right here. And we're with that with new ISO standards and revisions that have come up. So can you talk to us about the newest standard, the consequent, or revisions, and how that's affected Injectech's offering and even manufacturing processes?
Absolutely. So there's an ISO standard. It's ISO 80369, and this standard was implemented to prevent misconnections between devices. So historically, the Luer was the most common way to make tubing connections between devices. Unfortunately, there was historical deaths that have occurred in connecting wrong devices to each other. So the whole purpose of 80369 is to prevent those misconnections. They do that by assigning specific small bore configurations to device categories. So right now, there's currently 8 parts to ISO 80369. And I'll just break down the dash numbers.
Okay, yeah, that'd be great.
So, absolutely. So dash 1 provides the general requirements and guidelines. I'm going to skip to dash 20 because dash 20 defines the test methods such as the axial pullout requirements, the leak test requirements, and the stress testing.
Okay.
So that's the guidance portion of this. Then you get into the specific application designs.
Okay.
So you have dash 2, which was released last summer. Dash 2 is for breathing systems and driving gases. So really like the respiratory market.
Okay.
It was released last summer. There's no FDA guidance as of yet.
Okay.
As to when they're going to implement it and essentially mandate that respiratory companies adhere to this design standard.
Okay.
Dash 3 is for enteral applications. That one is released.
Okay.
Dash 4 is for urinary applications. That one's on hold for now. I believe the market is getting through the dash 2 before they actually focus and release the dash 4 urinary standard. Dash 5 is the connectors for limb cuff inflation applications, blood pressure cuffs, those types of products. That was the first one that was released probably over 5 years ago. Dash 6 is connectors for neuraxial applications. That one was released several years ago. And then we come to dash 7, which is connectors for intravascular or hypodermic applications. This is the traditional Luer lock and Luer slip connectors. This one was released a couple years ago.
So we have all of these, and we'll put a summary of these in the description of the podcast. So if you have other questions or you want to deep dive a little further, we can provide that resource for you. I know for those of you working on like application-based product lines, this is important information for you to know, and you might not be aware of it because it's not complete yet, or it hasn't affected you yet, but it's going to. But it has affected Injectech because of your vast product line. Tell us about the changes that you've had to make as a result of these new standards and revisions.
So I'm going to focus on 80369-7, which is the Luer standard.
Okay.
So we were the first company to market with the new Luer standard. The first thing that we noticed is that not all of our customers needed to make the change to the new standard because it focuses specifically on intravascular and hypodermic applications.
Sure.
Not all of our customers, have that in their product lines.
Right.
So what we did is we developed an internal product line extension. So this involved creating new tooling inserts and pins to meet the 80369-7 standard, while we still offer the old 594 product line standard products, so that our customers that aren't affected by this aren't forced to change to 80369-7.
Yeah, because for some of your well-established customers, design change, if you can avoid it, is the way to go. So that's a thoughtful way of handling that for your customers, for sure.
Definitely. So yeah, we have a full line of barbed Luer connectors, couplers, caps in the 594 version, and then we also have barbed and bond-in connectors that adhere to the 80369-7 standard.
That's great. So you talked about kind of the need for these. It's interesting when a standard is very applications based, and you mentioned 8 of these dashes, and I think 6 of them are application specific, and the importance of that. And you can, it's like you hate to say, well, duh, like it makes sense that we would want different, but for a long time there wasn't a regulation surrounding that, and there was a problem. So, I mean, continual improvement at its finest, right? The goal is to test these things before there's a mishap in the patient. And I appreciate that Injectech has been so quick to adopt those standards and be proactive there versus like waiting for everything to be, totally enforceable or something like that. You're kind of on the beginning front of it, being very proactive there. I want to say you had mentioned that you were the first to market a certain connector with a respiratory. Is that correct?
Correct. So 80369-2 is for breathing circuits. So 80369-2 has 2 different types of connectors. They have what they call an R1 connector, which is for low pressure applications, and then they have an R2 connector or connection that is for higher flow applications. So the R1 connection, we do have the cone and socket in various configurations that have been released. Again, first to market with these, and then the R2 connectors, that's a design project that we're currently working on. Okay,
that's awesome. So again, staying incredibly proactive. You've made Luers, I think you say they're backwards compatible basically to the 594 Luer. So you've got that going on as well. Can you tell me more about that?
Absolutely. So 80369-7 Luers are more stringent when it comes to dimensional requirements and testing requirements. Okay. So if you're looking at a 594 versus an 80369-7 Luer, the 80369-7 is going to be backwards compatible to the ISO 594 Luer. You cannot say the same for 594 going to 80369-7 due to the dimensional and test requirements.
Gotcha. That's perfect. So, you talked about for the respiratory one, some of the higher flow, higher pressure applications. How important is, asking questions about pressure in the beginning, those beginning conversations?
Oh, it's critical to understand which specific part of the circuit they're trying to connect to, and there's more definitions coming about which one would be R1 versus R2. So that's something that industry is working through as we speak.
That's good. You're so proactive on the quality side, and that's something that's really important. I think increasingly the R&D engineers are looking at that earlier on because, of course, every product wants to go to market. They don't want it to stay in the R&D phase. So they really do have to be asking those questions earlier and earlier. And I love that Injectech is always ready to answer those questions and ask questions that the R&D engineer doesn't even know. The product developer doesn't even know to ask at the time. They might be looking at a configuration and how it fits before they're asking for pressure or vice versa. And you're able to provide that meaningful feedback.
We like to read and fully understand the standards, and then extrapolate to our day-to-day asks from engineers and help explain it that way.
That's so good. So let's break it down into the three main tubing categories for your small bore medical fittings. You've got your Luer, your tube to tube, and filters and valves. Each serves a different connection type, pressure range, use case. And I know you've got this Resinex brand. I want to give a little shout out to them during that too. So, you have these various materials, various configurations. Can you tell us about them? And just give us maybe a framework to pull from for Luer fittings.
Absolutely. Yeah. So when it comes to lures, you have the male and female lure, and then you have lock versus slip. The lock has a threaded connector on it, whereas the slip does not have threads. Locking the lure locks, you want to use those for extra safety, if you will, on the connection, because the threads, along with the 6% taper of the lure taper, help complete the assembly. Right. Slip lures, they're used when you really don't have a lot of room for the bulkiness of the threads. Right. So that's the main differentiator between locks versus slips. Breaking our product line down further, we offer 6 different Barb sizes for different ID tubes. The Barb is a manual fit. You insert the Barb inside a piece of tubing. The OD, or outside dimension of the Barb, it provides a bite. And then behind the Barb, what we call the Barb stem, moving towards the center of the fitting, we actually ramp up the plastic. So when the tubing goes over, the ramp pushes the tubing back into that sharp Barb OD. Yeah. The other type of connector that we offer in lures is the bond-in connectors, which are typically found in IV applications, dialysis applications. And that's where you're going to glue the tube either to the outside or the inside of the connector.
Do you have a recommendation for that adhesive, or is that something that people need to know about, or is it something that you're going to advise on when they request that component?
We'll advise on it when they request the component, but the most common that we're aware of is cyclohexanone.
Okay. What about, we're working with fittings and we're doing our trainings, because it's funny. I don't know that fittings is our, biggest seller, highest product line. It's something, though, I think more than any other product line that we get the questions for. And I think because there are so many different configurations, so many different applications, and so many different tubing materials, it's all about matching that up together. And so how does Injectech help determine maybe the right style for the right tubing compatibility, the right style, configuration, material of the fitting based on the tubing that they're using? Because they go hand in hand.
So when it comes to Barb connectors, we ask for the ID of the tubing and obviously the type of tubing. Yeah. And we have, as I mentioned, 6 different sizes, standard sizes, and then we have 3 different styles. So we have our standard, what we call our standard Barb. We have our rigid Barb, which is intended for use with rigid tubing. Okay. Then we have our high flow Barb, which offers a greater through hole, and it kind of sits in between those. So when a customer is looking to fit a lure to their tubing in their application, we start with the ID of the tubing, and then we'll offer free drawings and free samples so they can actually get the components, see how easy or difficult it may be to insert it into their tubing, and continue onwards.
Yeah, and I know we've talked about, what's the rule of thumb for which materials pair best, and it's not just about that, it's also about like the kind of post-processing sterilization, things like that. And so, you can always advise them based on what that process is going to be, because not every product goes through those same processes.
Correct. Yeah. And when it comes to sterilization, we can give information from the resin manufacturers and their recommendations. However, again, we prefer to send out free samples so that our customers can test them in their exact sterilization environment.
Is it similar for pressure testing? Like you can give a range, but it really depends on the tubing. It really depends on the finished device too. Like there's I guess like catalog, maybe pressure rating of some kind in the industry. But then I think everyone really is like, but you test it to make sure. We don't know what you're doing with that.
Exactly. Yeah. And you hit the nail on the head. Our general statement for like our Barb connectors is they will hold 125 PSI.
Yeah.
But again, there's so many variables that you have to consider, the tubing, the material, the wall thickness.
Yeah. I try to say, we've seen people do this, but we can't recommend it. You have to test that. Because I don't even know if they're going to give us the full story. Right. Like not that they're intentionally withholding information, but we're just not there. We're not sitting next to them on the bench while they're testing this stuff. So they might be missing something. And I certainly don't want to be responsible for giving them the wrong advice.
Right. And free samples, it costs nothing to anyone. Yeah. So let's just figure it out that way.
That's exactly it. So when you're working with the engineers and we're talking about like the full system, what is the most overlooked thing from engineers? What do they most, when they're thinking about individual components instead of their full system, what are they missing out on?
In terms of the full system, I would really focus on design for manufacturability.
Oh, yeah.
Our medical plastics group, the new plastics group within Van Street, we're experts on finding the best way to manufacture devices while providing tooling and molding efficiencies that may have been overlooked.
Yeah. No, it's so true. You hate when people get so far into the process and then they realize this is too complicated to scale well. The time frame is too big. Yeah, so those are good conversations to have. Another like buzzword, we've got DFM, and it's like it's a buzzword, but it's real. Everyone's talking about it, but I'm so glad because it's going to make a huge difference in your project as you develop. The next one is the tolerance stack up, and I think this is really crucial in fluid management. What perhaps is the most common tolerance stack up problem that you see your engineers encountering?
The most common one that we see is when you're bonding tubing to a bond-in Luer. It's important to focus on the tolerance band for both the tubing and the connector. So what we do with our bonding connectors is we have an internal taper or a lead-in so that it will accept different variations and tolerances on the tubing.
Yeah.
However, what we're seeing is more stringent requests for us to hold our tolerance to, let's say, plus or minus 1,000ths or 2,000ths, because the OEM would like to seat the tube within the fitting at the same spot every time, or they want to avoid dead space within the connection.
Gotcha. Yeah, so you're able to catch that probably pretty early, though, as long as you're involved early in the process.
Absolutely, yeah. This typically, if it doesn't happen immediately, it'll happen once the engineer tests the samples. Has variability on the tubing, and takes a look at all that and says, "Wait a minute, this tube isn't seating exactly where I want it to." Mm-hmm. That's when it typically comes back. So yes, those conversations are held either immediately or very early on.
That's good. I love to hear that. Okay, so we know that not all materials are created equally. We've touched on this. We know that whether it's the way a drug interacts with a plastic, whether there's some kind of leaching issue, whether there's a sterilization change. When are engineers most caught off guard with material compatibility in their system?
So we like to try to head all of the questions off at the very beginning, by asking about the sterilization requirements, how they're using it. But one of the most common ones that we see at Injectech is where the plastic fitting fails or weakens in sterilization. Mm-hmm. We offer guidance on the sterilization methods and provide the free samples to test.
And you have so many different materials. Just because they can't, it doesn't work for this material doesn't mean they're at a dead end. There are other options that might better suit their application.
Yeah, we have probably about 10 standard materials
Yeah.
that we mold with. So if one doesn't work, we can always look at the next one.
Yeah, that's fantastic. And you can sterilize your materials before the finished the product is done. So if you really just need to put something through a system, sometimes they're not waiting until they get all the way down the road to sterilize the final prototype. They're seeing how this material works beforehand. So they have that ability with free samples, small quantities, things like that already.
100%.
When you're dealing with fluid management components, the goal is leak-free, right? If you're looking at the highest level, sometimes I put into it with medical device because I'm working with so many people. There's no way I can be an expert. I love to put into AI something like, explain this to me like I'm 5. And then I'm like, okay, that's too easy. Explain it to me like I'm 10. And I just keep going until I feel like it's an adequate response. But the bottom line is it's not a successful fluid management system if it's not leak-free, right? And so
Correct.
There's a functional leak that could happen. That's bad, but not as bad as a leak that might allow some kind of contamination. So what causes some of those leaks or connection issues that maybe people don't expect? What is your warning to them?
So with bonding connectors, the most common causes of leaks can be attributed to the wrong port size, a tubing tolerance issue, as we just discussed, not applying enough glue, or applying too much and creating stress cracking. And then we've also seen several cases where isopropyl alcohol has a degrading effect on some plastics, and it actually causes them to crack. And as we know, IPA is commonly used in the hospital setting. So
for sure. No, that's good to know. That's good advice for the end user, for sure. Make sure they're using the right stuff that's everywhere.
Absolutely, yeah. And then when you switch over to our barbed connectors where you don't need to use adhesive, we design those without a parting line on the actual barb, which is the sealing surface. So you shouldn't expect a leak on those connectors unless the barb is sized incorrectly.
Yeah. I feel like you've hit all the high notes, really, of what to look for first. Injectech is so proactive on having the conversations, and I'm sure you agree. There's no such thing as a stupid question. We'd rather just answer it early and get them in the right direction.
Absolutely, yep.
We talked about using off the shelf. We've talked about Injectech being a resource by providing not just guidance, but samples, supporting distribution with small quantities, things like that. I want to just maybe end with a few. I don't want to end with a few questions. I want to talk specifically about radiation stable. We've added that line. We're excited about it. Talk to us some about that off-the-shelf product and why it's important.
Certainly. So the majority of our components are going to withstand gamma, ETO, and E-beam sterilization methods. However, some of the materials will discolor after sterilization.
Right.
So we do have a radiation stable polycarbonate, and when that comes off our machines, it has a purple tint. Okay. So when you run that through gamma sterilization, it color shifts to clear so that you know it's been sterilized.
Oh, cool.
Conversely, clear polycarbonate, when you gamma sterilize that, it turns into a yellowish tint, which is not very appealing to the eye.
It is not. So, it looks old.
It looks old. It looks, absolutely.
It's been through a lot. It looks like it's been through a lot.
Yeah, it's had a tough life.
It's had a tough life. No, I think being proactive, it's nice to have the color as a guide. I love that it turns clear when it's done. It doesn't turn to a different color, but you have that kind of visual, yes, this process is done. We can move on. I know you have a couple of products that can withstand autoclaving, if I'm remembering correctly.
Correct. Yeah. So we have a line of off-the-shelf components that are manufactured in Kynar, which is PVDF. Okay. Kynar is extremely resilient to autoclaving. And then we also offer nylon connectors. And nylon is one where we literally send free samples because nylon will withstand a couple cycles of autoclave, but the parts may swell due to water absorption.
Yeah, so depending on the critical spec or depending on the application, that may or may not be acceptable.
Absolutely. Yep.
Let's move to rapid fire. So
Sure.
the goal is to answer in as few words as possible, but I have made the mistake of asking people to just use like one word, and they're like, impossible, Kristin. So you're not limited. You're not limited.
Okay.
Most common fitting mistake engineers make early in their career.
I'd say not seeking advice from fluid management experts.
Yep, and I would say that's in any application, right? Whether you're making a fluid management system or a tapered mandrel or something, when you're not getting your suppliers, your skilled manufacturers, your experts in that conversation early, it's a bad idea. See, I made the rapid fire longer. Unbelievable. Biggest misconception about ISO 80369.
That it's still far off in the future. You referenced that earlier in our conversation. It's here, and it's just a matter of time, so we should all start preparing for it.
I agree. I think it's why it's so good for manufacturers to be aware of the regulatory space, because I don't actually, I have a colleague who says, our brains are like an iceberg with penguins. There's only, and the penguins are the ideas or the thoughts or the information that you have. And once you fill that iceberg, penguins start falling off. So I don't think an R&D engineer has room always at the beginning stages for that regulatory penguin, right? They've got a lot of other things fighting for their attention. And I think it's why it's so important for manufacturers like you, who are so aware of what's coming up in the regulatory space and can really prepare the buyer, prepare the development engineer for what's to come.
Definitely. Yep.
Okay, Luer lock or Luer slip, when should you never use one over the other?
Luer lock, when you don't have the physical room in your application. And then the slip Luer, if there's a potential for bumping or dropping the connection, I would probably not recommend the slip that.
Yeah, that's good. One tubing fitting combination engineers should know better.
I would say understanding the potentials for polycarbonate to crack when it's glued to PVC tubing. And then also understanding that isopropyl alcohol can cause the polycarbonate to crack as well. That's
good. This is, we know the answer, but I'm asking anyway. How early should a fitting supplier be involved in a new device program?
We typically see this towards the beginning of the program.
As it should be.
So, yeah, as it should be. Yep.
All right. Standard or custom? What's your gut instinct when an engineer describes a typical IV infusion application?
Gut instinct is that it's going to be standard components that are off the shelf, unless they want to hold tighter tolerances on those parts, and then we'll get into the custom side of it.
That's perfect. Final question. What's the one thing you wish every medical engineer understood about fluid management systems, fluid management fittings, before they ever pick up the phone to call?
I'd say it'd be nice if they understood that there's a multitude of different connection types available. A lot of different companies manufacturing a lot of different types of components, and that most suppliers will offer free samples and resources for them to test. I'd say all of us are here to support the medical device and biomedical industries, and feel free to use our resources.
It's so true. I think more and more the mindset is we want to get in there early, want to help the development space early on so that we're not having to go back and clean up messes later. And I love the spirit in Injectech for that.
Well, thank you very much.
And thank you so much for being here. Thank you for the great conversation, Dave. It's so wonderful to see your face and get to talk all things Injectech. So exciting about the growth, all the big things to come, and I'm sure we'll have you back on soon.
Kristin, I appreciate the opportunity, and this was wonderful. Thank you very much.
All right, now let's go change the world.